Introducing aPriori.
Hello everyone, and welcome to today's webinar where we're going to be introducing sustainability insights from aPriori. My name is Mark Rushton. I'm a Senior Product Marketing Manager at aPriori, and I'm pleased to be joined by my colleagues today, Gibson Peters, our Sustainability Product Manager, as well as Daniel Patterson, Sustainability Senior Application Engineer. Today, we're going to look at aPriori's latest innovative solution, Sustainability Insights. During this webinar, we'll provide an overview of the current sustainability trends and initiatives in the manufacturing space. And then we'll look at how aPriori's Sustainability Insights equips manufacturers with the intelligence to measure, reduce, and report on a product's carbon footprint in real time during the design and production process. We're also going to hear from Grundfos's Tony Rasmussen, who's a Global Manager of Cost and Value Engineering, on his experience with leveraging sustainability insights thus far. So thanks for joining us. We've scheduled 60 minutes for today's session. Before we begin, a few housekeeping notes. Everyone's going to be on mute throughout the session. But if you have any questions, please use the Q&A icon on the navigation menu at the bottom of the screen and type in your inquiry, and we'll be answering those throughout. And we'll try and get as many of those answered before the end of the session as time allows. If we don't get to your question, don't worry, we'll answer that via email shortly after the session. This session will be recorded, so you'll be able to get a link and share that with anybody else who might be interested, and we'll also share a copy of the slides. So without that, let's begin. So today I'm going to introduce, for those that are not aware, I'm going to take a quick look at aPriori Technologies and who we are. Then we'll look at a background to sustainability insights and what challenges we hope to address with that product. Then we'll hand over to Gibson, who's going to introduce us to the capabilities of sustainability insights from aPriori. Then we've got the interview with Tony from Grundfos. Then we've got a demonstration, a live demonstration from Daniel Patterson, and then we'll end with a summary. So aPriori, we like to empower product developers and manufacturers with data-driven decisions for profitable and sustainable products. And we really unlock the value trapped in your digital twins through automated manufacturing insights. Our mission is to help customers create great products faster by empowering them to do more with every dollar they spend designing and manufacturing their products while minimizing the environmental impact. And we'll take a 3D CAD model or a digital twin and assess it for cost, manufacturability, and now sustainability. We've got some great success stories. Over 200 of the leaders in manufacturing rely on aPriori today. And some examples on the screen: Caterpillar managed to save over $1 million in 1 hour. Danfoss saved 20 to 30% consistently with new product introduction target costs. Alstom managed to save 40% through reduction in supplier costs through their zero RFQ initiative. And many other customers from many other industries also rely on aPriori today. And you can see we really do support all industries, and we've got some really big name customers in each industry that rely on aPriori to accelerate their business globally. So what are the challenges? What are the priorities in industrial manufacturing today? Well, inflation and margin pressure. More recently, that's been a hot topic. That's something that you can definitely help with aPriori. Mitigating supply chain risk with lots of disruption over the last couple of years. That's something that we can definitely address. Labor and skills gaps. That's always been a challenge in the engineering and manufacturing space, probably for the last 10 plus years. A lot of people are coming out of school and university ill-equipped for what's needed in the industry. And more recently, driving sustainability action. A lot of companies have made promises, but getting to that action is definitely a challenge. So how do we help with that? Well, all of the investments that you've already made in things like 3D CAD and PLM, we leverage those. We leverage the value that's locked away inside your digital twin by adding to it and giving you a continuous digital thread. Many companies focus on the digital twin of the product, which is great, but we extend that by giving you a digital twin of the process and also of the factory. And we enable the insights trapped within that to be unlocked around cost, manufacturing, manufacturability, and now cost and CO₂. So moving sustainability from intent to impact. Well, customers are demanding more sustainable products, and what's lacking is transparent data to prove it, to avoid greenwashing. And there's an immense amount of pressure from new legislation, new regulations like the EU taxonomy, and in the US, the proposals from the SEC. And even more recently, the carbon tax on imports that's been proposed in the EU as well. And the only other way to really do it is with complex, time-consuming and expensive full life cycle assessments. So we're here to help with all of these things. And manufacturing companies have a huge impact on world's energy consumption and also global emissions. So it's a big area that we can have a huge impact by driving efficiency and using our technology. Many companies, in some sectors, 100% of companies have some sort of sustainability strategy defined. They've made promises publicly, but only 40% believe they actually have the knowledge and the capabilities to achieve their targets, and we're helped to bridge that gap. And we've been providing the ability to act on cost and manufacturability for over 15 years, so we really know product development and manufacturing very well. And we're simply layering on top the ability to act on sustainability by taking what we know about manufacturing and allowing measurement of the carbon footprint of materials and processes used in the products that our customers design and build. And with that, I'm going to hand over to Gibson to talk about how we do that for sustainability.
Thanks, Mark. So as Mark mentioned, for us, it really starts with importing that 3D CAD model, selecting that digital factory. We automate the analysis, we do insights review, and then help you take action. And for the past 15 to 20 years, we've been really focused on cost and manufacturability. And what we're doing with sustainability is really layering on that capability for sustainability onto the cost models and the cost engine we've been developing for the past 15, 20 years that have we've been refining and optimizing with our customers. And for those of you who are not familiar, aPriori really focuses on should costing. We take the material costs, tooling setup, manufacturing process, assembly costs, and labor costs, and help determine a should cost, which is slightly different than a quota cost, as it should costing as it sounds, how much a product should cost to make. And this really fits nicely into the demands of what sustainability is asking from our customers are asking about sustainability. So, material costs, we understand rough mass, we understand regrind, remelt, we understand utilization. We multiply that by the material CO₂ factor to help you get a material CO₂ calculation for your product. When it comes to the manufacturing process, we've spent a lot of time understanding the cycle time of many different products and processes. I think we have over 440 different processes developed, understanding the energy use for different machines within those products and processes, and then layering on the electricity mix factor to multiply that by the energy used to come up with a process CO₂. And what we found throughout our process is there's four main layers. What is the shape and geometry of the product? What is it made out of? The material, how it's made, the manufacturing process, and where it's made, the location, electricity mix. And I think more and more as we dive into this and learn more about sustainability and how we make products more sustainability and design them to be more sustainable is, these are really dependent on each other. So if I change the geometry and the shape, I can look at changing the material, look at changing the manufacturer process. So understanding how these different variables are dependent on each other really is really important to understanding both the cost and the sustainability impact and helping you optimize for both that cost and sustainability. So, just to give you an overview of what some of our customers are doing, working with global truck manufacturer, they're helping, I think, everybody starting with creating that baseline of existing products. So how much carbon is in my existing products? And then looking for ways to reduce the CO2 in their products. So this customer is looking at reducing CO2 by switching from metal components to plastic components. And it's the first solution they've really seen that it can help them meet their ambitious CO2 goals. Another customer of ours is also looking to automate the creation of CO2 baselines with existing products and really equipping their design teams with insights when they start talking about the circularity design or how they make products more sustainable. And then finally, we are working with a manufacturer cycle of aluminum products, and they're using aPriori as a sales tool to help customers understand the carbon impacts of using recycled material or materials with a lower carbon footprint. So I think there's a lot of different ways that we've seen customers utilize our product, and it's really exciting to see ways we have initially thought of and our customers running with the insights we're able to provide. So we've been going through a beta process or an early adopter program. We've had a lot of success with those early customers. This is one quote from Tristan Aben with Carrier. And I think it highlights how they're looking at moving carbon from baselining and moving design, but also their intent to integrate this with their PLM. So each part they manufacture will have a carbon footprint in their PLM system. So helping them understand the carbon footprint, but also automating this process so that it's clear and transparent for all the different stakeholders when it comes to cost and sustainability. And then finally, what we wanted to talk about is earlier this month, we had a chance to catch up with Tony Rasmussen, Global Manager of Cost and Value for Grundfos.
It actually kind of started out, when we started to see all these increasing energy prices that were coming up. And we were meeting more and more requests on to see, what is the actual impact on our price related directly into the source of energy that we use. And the good thing about aPriori is that it is actually throughout most of the processes, it's actually quite precise, but because we choose a machine with a power motor on it and so on and so on. And then I was also engaged here with aPriori to kind of fine-tune some of those things and develop even further on some of those aspects. And in that sense, we actually started also to discuss the whole carbon footprint aspect of the situation, and we were actually kind of laying the foundation for that, because to be able to calculate the carbon footprint, you first of all need to be able to calculate your energy consumption throughout the entire range of your process flow, and had the agreement that Grundfos was probably one of the pioneers on this field, with a handful of other customers at that point. So it's been a year now, and we are actually in a very good stage, I would say, on this. I was quite happy with what I was presented in the meeting last week. So we have already, I think it's 4 of the cost models where we are able to to extract or apply carbon footprint features on some of the things. It's still on a beta version, and so we are still tweaking and working with it, but it definitely have some the right direction. I think that the main benefits in terms of carbon footprint is it's basically, you know, the same benefit that you get when you do your, you know, your cost calculations. You are able to break down your cost into you know, really tiny details, or at least to the level where you see, okay, this is actually what's important for us. This is what is driving the cost. If we can, you know, tweak here and there, and if we can change some things here, we can actually you know, influence the cost. And that's a good thing, because aPriori is so good at breaking things down, and you get a clear understanding. And you can just flip that over to the carbon footprint, because I sometimes say that when we start to work with carbon footprint, we start to talk about, you know, how many tons of carbon. That amount of ton will have a value. It will have a dollar value. So we are actually more or less just talking about a new currency. You know, we can talk about the dollar on the cost side, but we can also in the future start to talk about dollars on the carbon side. And you know what? If we want to go down on the carbon footprint, we need to have optimized processes with lower cycle times. We need to have, you know, choose the right material, choose the right processes. And also in aPriori, where we can kind of, you know, calculate from different regions, because due to the grid mix that we have, for instance, for Denmark, Germany, Poland, we can try to flip things around to see what is the carbon emission actually, if we start to also look at it from that perspective. I think right now where I maybe see the biggest impact is within our engineering organizations, when they're sitting in the early phase, the design engineers, because also moving forward, we start to see that, you know, developing products that can reduce carbon footprint, that starts slowly to also become a target. You know, before they were talking about quality, efficiency, cost, and so on, but now also for carbon footprint. And where I think that the carbon footprint feature in aPriori will, you know, really have an impact is, again, you know, coming back to the cost, we are actually able to quantify and, you know, drill down to see where do we actually have the emission here, and what can we do to work with it. How can I change my design, maybe from volume of the part, from a gray cast iron to a manufacturing process method, to a supply chain setup based on, you know, where is this actually ending up? Which assembly factory do we need to deliver this to? Maybe we need to change something from being produced in China instead of moving it to a production site in Europe, because this is basically where we need to use it at the end user factory, at the assembly factory. Simply because we can actually see that there is a carbon impact from supply chain. Definitely, aPriori is on, you know, the whole carbon modeling feature that we're working on is definitely a part of our strategy.
Thanks, Tony, for that wonderful conversation about sustainability and how you're using aPriori to meet your sustainability goals. Really, what we've been building the Sustainability Insights platform here at aPriori is to calculate faster, more precise modeling by leveraging the 3D tools that you have at your disposal. So you load the 3D CAD model, and we're helping you to understand within a few seconds how much carbon is in those products. Second is, once we have that information, helping you create actionable insights from trade-offs between CO2 and costs, while ensuring manufacturability of these different products. And then finally, giving you the confidence, the transparency, and configurability with proven manufacturing insights that can help you model those CO₂ emissions. And with that, I'll turn it over to Daniel Patterson to give a demo of aPriori sustainability insights.
So let's walk through a live demonstration now. So what I'll do is we'll go through and we're going to evaluate an injection molded design. So I'll evaluate that in aPriori, and we're going to assess alternative suppliers, consider different materials, and then compare design iterations as well. So when we're going to evaluate a design, we're going to look at manufacturability, cost, and sustainability in parallel. So let's switch over to aPriori now. Now that we're in aPriori, there's only the few main inputs for running an analysis, whether it's sustainability, cost, or manufacturability. So here we've pointed to the CAD file that we'd like to evaluate. We need to just answer those 4 basic questions you may be familiar with. What's your primary method of manufacturing? In this case, plastic molding. Where would you like to manufacture this? So we're going to look at this in China. What material and what annual volume? So at this point, aPriori will run through an analysis based off of those 4 primary inputs. So we'll take this, we'll process that through, and we'll come back with our analysis of cost, manufacturability, and sustainability. So if we come over here, we have our familiar bottoms-up analysis for cost. We have 22 cents of material, we have labor, we have overhead, giving us a $2.22 component in China currently. We also have the ability, as usual, to see manufacturing issues, whether it's draft angle issues, whether it's hole proximity, whether it's minimum wall thickness. All of this remains the same, whether we're running an analysis looking at cost or sustainability or manufacturability. But now what we have the ability to do is understand, based off of our design, based off of our material, and based off of our region, what's the CO₂ impact. So we can see the total CO₂ for this design is 1.41 kilograms of CO₂ equivalent. It's broken out by about 0.61 is coming from the material itself, and about 0.8 is coming from that process. If we were to dive into that, we can actually see what's driving that. So what's the electricity factor of that region around the process? So we're going to understand the CO₂ implications of that power grid in that region, as well as the energy consumption for producing that part. So this is based off of a bottoms-up analysis of cycle time for this part, understanding the cooling of the material, understanding how that geometry of the part drives it. So let's come and let's look at this. Let's move this over, for example, to a different supplier. So we know that we've been having supply chain issues from China. So let's move this over and see what would happen if we move this to Eastern Europe. So we want to maintain the part geometry, but let's just move this over to Eastern Europe, for example. So I'm just going to create a different scenario to analyze that. And then let's run our analysis with Eastern Europe. So we'll move it from China to Eastern Europe. We had a change in cost. We went from $2.22 to $2.57. Let's come over and look at the CO₂ though. So we went from 1.4 kilograms of CO₂ to 1.11. So we're moving the right direction here based off of this. It's sustainability wise, the cost did go up. But let's look at another version and see what would happen if we were to move this to Western Europe, for example. So let's create another scenario, this time for Western Europe, and let's see what this does for our overall sustainability. Same design, now in Western Europe, it went from $2.57 in Eastern to $3.77 in Western Europe. Let's see though, our CO₂ went down once again. So now we're at 0.86 from that original starting point of 1.4 in China. So our CO2 has gone down, but our cost has gone up. And let's look at one final example. Let's look at this in the USA and see where we are cost-wise. And moving from Western Europe to USA, we had another cost increase. We went from $3.77 to $4.18. And then we can check our sustainability. We went from 1.01 in the US currently, and let's compare that back to Western Europe at 0.86. So not only did we have a cost increase by moving this to the US, but we also had an increase in carbon by producing this in the US based off of that regional energy grid. So let's look at what we just covered. So we looked at this injection molded part. We automatically optimize for process and feasibility. We identify those cost and quality drivers, and we provide suggestions, whether it's wall thickness or draft angle. We provide a detailed analysis of cost so you can understand whether it's material or labor or overhead that's driving that cost. And then finally, we provide that CO2 equivalent for the material and manufacturing so you can understand what's driving it based off the region where you're manufacturing the part. Is it the electricity from that region? Is it the material itself? All of this will go into your overall analysis. So now let's go through and look at different materials and see what that does to manufacturing feasibility, cost, and sustainability. So now let's look at this design and let's change our materials. So let's come over to our sustainability guidance and let's look at our material. So here we can see in the US right now, about 60% of our overall CO2 is coming from that material. About 40% is coming from the processing. So let's go through and let's actually look at some different materials. So we have it costed with ABS currently. Let's open it up and look at all materials. So now we have the ability to sort based off of the carbon of the material, the emissions factor, as well as the cost per volume. So we can actually go through and really understand what would give us a reduction in carbon. So sorting from that lowest carbon to the top, we have that ability to see what's the emissions factor of those different materials. So here we're looking at our ABS, we're at 0.47 for carbon. We have the ability to sort and see what those different materials are. So let's find a similar material. For example, here we have a PBT material. It's going to be a similar density, a little bit higher. The cost per volume is going to be a little bit lower. Let's run it with this PBT material and see what that does to our overall carbon. So we were at 1.01 grams of kilograms of carbon. Let's rerun that and see what that does. So moving to that PBT material had a large reduction in the overall total carbon. So we went from 1.01 to 0.58, so almost cut the carbon in half. But let's come over and look at cost. And cost went the correct direction as well. So we went from $4.18 down to $1.80. We had a reduction in material, labor, and overhead based off of this new material. So we'll do that bottoms up analysis to understand the cycle time associated with processing that specific material. So we've just touched on manufacturability, cost, and sustainability, looking at different materials. So you can go through and cost a material individually, or you can tell aPriori to go off and cost the part with all of my materials and come back with that lowest cost feasible material. All the while calculating sustainability. So you can understand the impacts of material change on manufacturability, cost, and sustainability. So let's take this design now and do some iterations on the design itself so we can compare those different design iterations and look at manufacturability, cost, and sustainability for different versions of this design, leveraging the feedback from aPriori. So let's dive back into our design and let's focus on understanding the manufacturability, cost, and sustainability with looking at some design iterations. So let's dive into our design guidance and look at our potential manufacturing issues. So if we come over here, we can see our list of potential manufacturing issues. We have some draft angle issues, some hole proximity, but let's focus on this maximum wall thickness. So here with this current design, we've calculated a maximum wall thickness of 16.5 millimeters, and that's that's greater than the 3.1 that's recommended for this material. So let's dive in and see specifically where on that model that material issue is. So let's go into our transparent mode, and we can actually highlight that specific area where there's a thickness violation. So right in the middle is our biggest thickness violation on that boss, as well as the ribs on the side have some thickness violations. So let's fast forward and look at a different design version of this. So let's go through and remove some of that thickness. So let's look and see what we can do for a different design here. So here I've got my revised design, taking that material, coring out some of the material in those thickest spots. So let's see where we are cost-wise. So right now we're at $1.70 for this design with $24,000 of tooling. Let's look and see where we are with our original. So we were at $1.80 with about almost $17,000 of tooling. So we've reduced the cost a little bit. Let's see what that does to our overall sustainability. So here we're at 0.58 kilograms of carbon. Let's look at this with our revised design. So 0.43, so we're moving the right direction. That material wall thickness has a large implication on the cooling time of the design. So the thicker the material, the longer it takes for that material to cool. So with our design, we have added some additional tooling to the part. It's resulted in 4 lifters for this cutout material. That's reflected in that tooling charge, the $24,000 instead of that $16,000. Let's fast forward one more time and look at this and see what would happen if we were to eliminate those side actions, go from 1 thick rib on each side to 2 thinner ribs, eliminating all that action. So let's see where we are cost-wise. So right now we're moving the correct direction cost-wise. We went from $1.80 to $1.70, now down to $1.46. We dropped our tooling charge closer to that original charge of $16,000. And let's see where we are sustainability. So that moved the right direction as well, 0.38 kilograms of carbon overall. So if we look back at that second design, it was 0.43. And then looking at that original 0.58. So we've moved the correct direction by minimizing that thickness of the part based off of the design guidance. So here we have the ability to optimize for manufacturability, cost, and sustainability in parallel. So based off of changing that design, we were able to reduce the cycle time. This led to a reduction in cost, as well as a reduction in that CO₂. So reducing that material can have a very large impact on all 3 of these. And then in summary, we've evaluated an injection molded design. We've looked at potential quality issues, cost driving issues, as well as assessed alternative suppliers and alternative materials. And then we further refined our design by looking at design iterations to maximize the design based off of feedback from aPriori.
Thanks, Daniel. Great job there. Really, really good overview of what's possible. So hopefully you saw from Gibson's overview of the product and Daniel's demonstration, sustainability with aPriori is really going to help you achieve your goals faster with more precise modeling of the manufacturing process by leveraging that 3D CAD data or digital twin. And it goes beyond just baselining and reporting. It really gives you the actionable insights from being able to do trade-off analysis between cost and CO2 and different processes and different designs. And the key is really giving you transparent and configurable, proven manufacturing insights that can leverage our knowledge of the manufacturing process and give you CO2 equivalent emissions from that process. And so, as I mentioned, the transparent and actionable insights on sustainability can be used either interactively on component and assembly level, like Daniel showed in the demonstration, but using our analytics built into the platform, it can help you to identify outliers for both cost and CO2 emissions. Not only cost varies based on where you're manufacturing globally, but also the CO2 emissions. And that's something that you can look at a high level as well. But really the key is to enable access to carbon data at a product level, which is quite unique in this space. So hopefully you can see how we can really help move you from intent to impact. And that there are, as you saw with the interview with Tony and quotes from Tristan at Carrier, you can join others that are already leading the way. You can start to address how customers are demanding more sustainable products by providing that transparent, precise carbon data and win more business from having that. You'll be able to get ahead of upcoming regulations and avoid inevitable penalties, and save time and cost by engineering out carbon earlier in the process rather than trying to do it once everything's finalized. So thanks very much for joining us today. If you want to learn more, you can visit our website devoted to sustainability at apriori.com/sustainability. And now I think we can take a look at any questions. So we'll see if any have been entered into the Q&A section. Okay, so this question just come in. Gibson, a good one for you. Question, do you require any additional inputs to get carbon footprint data out from a 3D CAD model on top of what you need to generate a cost?
That's a great question. No, I mean, one of the powers of aPriori is we take that 3D CAD modeling, some user inputs, basically like what process you want to use, where this product is being located, the volume produced in annual volume, right? And we generate the carbon footprint just at the same time we do cost. So it's really integrated with our cost engine. So you're able to see both those costs and carbon outputs at the same time.
Thanks, Gibson. Then another question is how are you different to the calculations done in life cycle assessment tools?
That's another great question. I think the big thing, as we talk more and more with customers using life cycle tools, life cycle assessment tools, is the speed of the feedback when you get the with aPriori is it within seconds instead of what we've heard customers using is weeks and months. But also, I forgot the original question.
But how are we different to life cycle assessment tools?
The other big thing is our accuracy when it comes to understanding the rough mass calculations. Everybody knows what the finished mass is and can calculate, oh, there's 1 kilogram of steel in this part. But what we really specialize is, well, to end up with that 1 kilogram of steel, you actually needed 2 kilograms of steel and be able to calculate that based on our years of experience doing cost analysis. And then finally, the last part that really separates us is understanding the cycle time to manufacture individual parts. So the cycle time coupled with the material allows you to make those trade-offs that are often lost in life cycle assessment. So, oh, I can change my material, I can change the shape, even though the mass stays the same or the process changes. We'll be able to highlight those differences in the design in the manufacturing process, so you can see a reduction in carbon, and the design changes impact on that carbon of that product. It's at the same time as the cost.
Cool, thanks, Gibson. Yeah, hopefully that answers the question. I mean, just a couple of points to reiterate there. You really do, with aPriori, you really do get manufacturability, cost, and sustainability insights in one step. And it is ready to go out of the box, but if you do need to customize it, if you're getting data from other sources, it's very granular and you can customize it as much as you need. But being able to run trade-off analyses between different designs, different materials, processes, or locations is really does help with that data-driven decision making. Just to identify where the biggest contributors are to both cost and CO₂. With our knowledge of manufacturing, our manufacturing simulation, with over 15 years, as has been mentioned a couple of times, really does give us a very good foundation to build on and add sustainability data to. And it can be fully automated. So in Daniel's demo, it was very interactive at a part level, an assembly level, but you can fully automate it. You can connect it to your PLM system. There is a lot more that you can do beyond what you've seen today. So again, thank you very much for your attendance, and please get in touch with any other questions, and we'd like to help you in this area. So thanks very much for your time today.
Thank you.
aPriori, making profitability and sustainability a reality for a better world.